Hello and welcome to my video, lesson 4.4, adding and subtracting rational expressions. So to begin with here, I just want to remind you guys when we're talking about rational expressions, we're basically talking about fractions. So if we look at these, we have two fractions and we're subtracting them. So the rules kind of apply as we're going to do here as we will with our polynomials, except that we add on our polynomial rules. Okay? So here, let's take a look. If we're adding and subtracting rational expressions or fractions, we need to have common denominators. So to do that, what we do is we take the denominator on one side and we multiply it by the other. And we take the denominator on the other side and you multiply it by this side. So what you'll have if you do that is 5 over 15 plus 6 over 15. And so if we add that together, it's 11 over 15 as our final answer. Same thing with subtracting. We just go multiply by 6, multiply by 6. We do multiply by 4, multiply by 4. And then we rewrite it out. So 18 over 24 minus 4 over 24. And if we simplify that, we can get to, so again, subtracting just the top, so it's 14 over 24. And now you can realize that you can actually simplify this, so it's 7 over 12. Now, if we look back more carefully, we actually could have noticed that there may have been simpler options here to multiply to make these common denominators. So let's try doing that. What if, instead of multiplying by 6 and 4, we multiply by 3 and by 2? Okay, well what we'd get is 9 over 12 minus 2 over 12. And so that would subtract and we get 7 over 12. And you can see it doesn't really matter the order, but I find it usually easier if you notice it ahead of time and you can simplify ahead of time, then do that and it will be a little bit simpler. But if you don't, you'll still get to the same answer. Okay, so that is just fractions, but what about rational expressions? Well, with rational expressions, we actually have to add a little bit, but not too much to our process. So we need to factor the denominator first. That is our first step. Find our NPVs. Then we can make common denominators and simplify, add, subtract, cancel out terms, etc. Okay, so first step here is we want to factor the denominator. So the first one is going to be, actually, let's do it this way so it's a little bit more clear. Right, we're going to do 1 over, and this first one is the difference of squares. So square root the first term, which gives us x, and then square root the second term, which gives us 1, and so we put plus minus, plus x plus 2 on top, and then we're going to have, this one is going to be PSA method, product sum answer, so we're looking at the 3. What two numbers multiply to get 3? Well, it's 3 and 1. Okay, and then we have to get two numbers that to add to get 4. So 3 and 1, if we add both of them instead of subtracting, yes, that will get 4. So now we finally have a factored denominator, step 1. Okay, step 2, find the NPVs. So we're going to write down our NPVs, and we're going to say that we have x cannot equal minus 1, minus 3, or plus 1. So those are all our NPVs, okay, based off of the denominator. So minus 1, plus 1, and we already have a minus 1, so we don't need that one, and minus 3 there. Okay, next, make common denominators. So we're going to do that one next. What we have to do is, if we already have something common, we can actually skip that part, but then we're going to follow the same rules as the fractions above. Multiply the denominator of one side by the other side to make common denominators. So here, Oh, I wonder if this is going to make it too complicated. I think I made my questions too hard. But that's okay. I think we can leave it factored. You know what? It'll be fine. It'll be fine. Okay, so we're going to take the x minus 1, and we're going to times it on the other side, and the x plus 3 and times it on the first side. So 1 times by x plus 3. So you guys can see how that would be added. And we're going to have the original part is going to stay the same. So x plus 1, x minus 1, and then we're going to have x plus 3. Okay, so you can see how I've just added the green part to this equation. And then we have plus, we have x plus 2, and at the bottom we still have our old x plus 1, x plus 3, right? But now we're multiplying by the x minus 1 on the top and on the bottom. Okay, because now if you look at the fraction, we actually have common denominators. So we're going to write this out all as one thing, so it's nice and clear with common denominators. Okay, on the left side, on top we have x plus 3, and we have on the right side, we can multiply that out, so we'll have x squared plus x minus 2. Okay, so now we have common denominators, and now our last step is to simplify and add, subtract, etc. So the top we need to simplify, so we're going to end up with x squared plus 2x plus 1. And on the bottom we still have the whole kit and caboodle. I don't actually know what that means, but the whole thing. Heard that before somewhere. I don't know where. Okay, and now that we've added and subtracted the numerator, we're going to actually simplify. So what we're going to do to simplify is factor the top and see if anything can cancel. So simplify, so the top, we can actually do PSA. This is going to be, this is a very complicated example, basically as complicated as it can get so that you guys can see, basically, yeah, as hard as it can possibly be. So plus 1, and then on the bottom we've got x plus 1, x plus 3, x minus 1. And now finally we can cancel out terms on the top and bottom. We've got x plus 1, x plus 1. And so we're finally just left with, maybe I can move stuff around, hold on. Maybe if I go like this, I can move it over this way. Okay, so now we're finally left with x plus 1, x plus 3, x minus 1. And that is our final answer, plus our NPVs. Okay, so it took a little bit of work, but we got there. Now I want you guys to try this question down here. This is subtracting. Okay, so pause it, try it out. One hint is if we're subtracting, we have to multiply in, okay? All right, if you haven't paused it yet, please do try it out. Now I'm going to do it. So first step, factor the denominator. So we're going to go through and factor the denominator. 2x. For this first one, it's PSA, product sum answer. So we have two things have to multiply to get -2. So we have 2 and 1. And then they have to add to a positive 1. So if we have the positive 2, -1, that'll work. And the other side, the top cannot be factored, but we don't want it anyway. But the bottom can have an x come out. Right? So we can do that. Now that we've done that, Before we couldn't tell, but now we can. We can tell what the NPVs are, and we can then also tell that we have some common denominators. So first of all, NPV, we have that x, so I guess I'll write here, NPV is that x cannot equal negative 2, 0, or positive 1. Okay, so that's the first part, and then we can get common denominators. So if we rewrite it out exactly as is, 2x, x minus 1, x plus 2. Now we can take the extra part on the right side and multiply it in. So the extra part here is an x. Whoops. X. All right. And then on the left side, we're going to do the same sort of thing. So x plus 2. Here we have x plus 2. And the extra part is that we're multiplying the x minus 1 in. X minus 1. Okay, now that means we actually have common denominators, which means we can write it as a common denominator, which is really helpful. So x plus 1 lets us be nice and lazy. On this side, we have 2x squared. On the other side, we have a big negative polynomial. So what's this going to be here? 3x squared minus 3 minus x minus 2. Okay, so that's what we have so far. Now we need to simplify. So the top, we can actually simplify it. I'm just writing out the bottom right now. X plus 1. Okay, so the top we can simplify to, first of all, multiply this negative into the exponents, or into the brackets. This is super key. So it's going to flip a bunch of things, like a bunch of signs. So we're going to have this. And then the plus, it's going to be a minus. So it's going to be minus x squared. Okay, now it's possible that this is factorable. So the only way to tell is if we take out the minus in front of the x squared. Otherwise, it's too challenging, at least for me. So I'm going to take out the minus. And we're going to be left with minus x minus 2. At the bottom, we've got x plus 2, x plus 1. Now we're going to factor the top. So we have x plus 1, and we have x minus 2. And at the bottom, we have x plus 1, oh boy, and x plus 2, close. I thought it was going to be minus 2 for a second there. Okay, so we're doing great, but now we can also cancel out these leftover parts. So now we're left with a final answer of negative x minus 2 over x plus 2. All right, this can be challenging, absolutely. I just want to encourage you by telling you this is the most challenging that these questions can possibly get. They shouldn't get any more challenging than this, but these are the most complicated examples. We went through some more simple examples to build up to this in class, but I hope that these videos helped you understand adding and subtracting rational expressions. Good luck.